Okay, again, the first step is determine the domain. In this case, the only possibility of restriction is when the square root x squared plus 1 get the denominator expression should be 0. This equation have no solution. It's obvious, right? Because this is always positive, never is 0. So no solution, therefore the domain is a real number. Okay, let's go now to the Y-intercept. Y-intercept, evaluate the function in 0 is equal 0 over square root 0 squared plus 1. It's obvious 0. Okay, therefore the point is 0, 0, 0. 0, 0 is both x and y intercept. Let me try x-intercept. The formula for finding x-intercept is h of x equals 0. H of x is x over square root x squared plus 1 equals 0. The responsibility to be 0 is only the numerator part is x equals 0. This is equivalent to say x equals 0, and this is never 0. Okay, confirmation 0, 0 is both is y-intercept and x-intercept. Okay, now let's analyze the asymptote. Well, we have no vertical. It's obvious, right? No vertical asymptote because we have no value undefined. So 0 denominator is the only possibility to have a vertical asymptote. But horizontal, yes. Horizontal, remember, is the aim behavior. So horizontal asymptote. You apply the limit when the x approaches to positive infinity, or when approaching to negative infinity, in both directions of the original expression is x over square root x squared plus 1. In both cases you apply dominant. This is equivalent to say x over square root x squared. This is x over absolute value x. When the value is positive, absolute value is equal the same, so x equal x. The answer is what? Easy. You know this procedure, and this is exactly the same. But what's the difference? The difference now is the value is negative, the absolute value is negative x. So it's x over negative x. The answer is negative 1. So we have two horizontal asymptotes. One in positive 1 and one in negative 1. This is the aim behavior in this direction, and this is the aim behavior in another direction. Okay, super. Now the calculus part. Apply or find the first derivative. Quotient root. Denominator square. Well, when you square root x squared plus 1, a square, it's obvious that square root and square cancel out, and stay only x squared plus 1. Derivative of the numerator 1 times derivative of this, well, let me express in different way like that, x squared plus 1 raised to the half power. Entonces, bueno, this is a copy exactly the same. Minus derivative of the expression in the bottom is 1/2 x squared plus 1 raised to the negative half times 2x. Okay, the derivative of this part. Time, don't forget the numerator, que is x. This 2 is cancelled. Okay, we have h prime in x is equal just x squared plus 1 in the denominator. Radical x squared plus 1 minus x squared, where come from x squared, x times x, and this is a negative exponent, is a reciprocal. Okay, now you put together, this is x squared plus 1 you condensing this in only one common denominator is radical x squared plus 1. This time this is x squared plus 1 minus x squared. It is cancelled. Okay, so the first derivative is 1 over x squared plus 1 times radical x squared plus 1. Okay. Okay. If you analyze this expression, no, never is 0. Never is 0. It's obvious, right? Because of 1 in the top. Impossible. And also, never is negative. And also, always is possible. Because this is positive, this is also positive. Positive divided by positive, positive. That means the function always is increasing. Increasing function. Always. And we have no local maximum, local minimum. No, we have no. Okay, good. Let's go now to the second derivative test. Well, to find the second derivative, I need to manipulate a little bit this expression. This is 1, and this is x squared plus 1 raised to the 1 power, and this is 1/2, and 1/2, and 1 is 3/2. X squared plus 1 raised to the 3/2. Actually is x squared plus 1 raised to the minus 3/2. Okay, now ready to apply the second derivative. The second derivative is minus 3/2. This point go to the front as a factor. Now x squared plus 1 raised to the minus 1 is negative 5 over 2, because negative 3 over 2 minus 1 is negative 2 over 2, and negative 5 over 2 times the derivative of this expression is 2x. Okay, let me try to, well, these 2 is cancelled. So we have minus 3x divided by negative exponent, again is x squared plus 1 raised to the positive 5 over 2. And this expression is always positive, and this entire expression is always negative. So it's always negative. That means no, always negative, depending on the value of the x. No. Okay, you find, of course, the inflection point. The inflection point is equal to 0. Okay, I don't care the denominator, I only care the numerator. So x is 0. X is 0 is a potential inflection point. I need to test it using the second derivative test. 0 here. Okay, I select 1 and negative 1. You evaluate 1 and negative 1 in the second derivative expression. Negative 1 and positive 1. I put in a calculator in order to save time. You trust me, this is positive value and this is negative value. That means n1 is concave down and negative 1 is concave up. Conclusion, 0 is inflection point. And you remember that 0 is 0,0, so 0,0. There's the x-intercept, there's y-intercept, and also it's inflection point. Okay, we are ready to see the simulation, decimal simulation. Okay, I type in the original expression, We investigate, remember we have two horizontal asymptote and one and the other one. Look. And the second derivative, one of the functions is always increasing. We have no local maximum, no local minimum, no. And the inflection point is at 0. Look, this is less than 0, the second derivative. This is concave down, in that part. And this is greater than 0, is concave up. Perfect.